Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Tonight we're going to take a look at some Pi Day math activities to get your students really excited about what they may be eating, but more importantly, engaged in some really great math on Pi Day. My name is Mike Houston, and I'm a moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make those tough to teach, tough to learn concepts accessible to all my students. I'm really excited to be joined tonight by our two panelists, Robin Polson and Tammy Casey. Robin has been a T-Cube instructor since 2013 and graduated a New York State Master Teacher Fellowship in April 2014. Robin taught many levels of mathematics, and recently Robin was published in the New York State Mathematics Teacher Journal by co-authoring an article titled "Problem Solved, We Flipped Our Classrooms" with colleague and fellow master teacher Tammy Casey, who's also with us tonight. So Robin, thanks so much for being with us tonight.
Thanks for having me, Mike.
And her partner in crime, Tammy, lives in also Lake Placid, New York, where she teaches grades 9 through 12. She's currently the math department chair at Lake Placid Central School. Tammy involves her students in problem-solving activities and discovery-based learning activities that allow them to think outside the box and truly learn how to apply the math they see in the classroom. In 2013, Tammy was accepted as a New York State Master Teacher, and she truly enjoys working with teachers to improve the quality of math education for all students. Tammy, so glad to have you with us tonight.
Thanks, Mike. I'm happy to be here.
We're expecting a large crowd, so your audio is muted. Feel free to send any questions throughout the webinar to Tammy or Robin using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. Some of you are already included where you're from, which is great. We have a really broad population on tonight, so it's great to see so many people from so many places across the world, not just the United States. This session is being recorded, and we'll provide a link to the event certificate of attendance, as well as a link for the documents that are being used tonight at the conclusion of the webinar. We hope you don't have any audio issues, but in the event that you do, find your name in the participant window. In that same window will be a little icon that looks like a phone. By clicking that phone icon, you will receive call-in information. And you can change from the audio broadcast, which is the default, to using your phone, which should alleviate any further audio issues. At this point, Robin is going to discuss our agenda.
Thanks, Mike. Our brief agenda tonight, we'll do some welcome and introductions, which we've already done. We'll also show you many ways to discover Pi using the 84 T-Nspire technology, as well as some TI coding. Our hope also is that at the end of the evening, we'll have a chance to hear from our participants in the chat window about other activities that maybe they do with their students to help excite them about Pi Day.
Thanks so much, Robin. And Tammy is going to discuss our expected outcomes.
So by the end of this session, what we're hoping is that you'll be able to use geometry pages to discover Pi in middle and high school grade levels. We're also going to look at how to use data and listen spreadsheets from data to capture values to discover Pi. And then we're going to look at some basic programming for both the 84 and the TI-Nspire. And then hopefully look at some other additional activities that you can use to excite your students for Pi Day.
Thanks so much, Tammy. And Tammy, while we're switching over and giving you control, feel free, if you have any thoughts about what you might do that you think is unique in your classroom for Pi Day, feel free to share those thoughts in the chat window, and maybe we can all learn a little bit from each other tonight, so that'd be great. Tammy, it's all yours. Feel free to share your screen. You're all set.
All right, thanks, Michael. So Pi Day is one of our most favorite activities or celebrations for our high school classes. We've been celebrating Pi Day for many years in Lake Placid, and we're so excited tonight to be able to share with you a few activities that we've actually used with our students in our classes.
So we have a bit of a bigger agenda on this page, but again, it's what we talked about earlier. What we've done is we started with a real basic geometry page that you could just send to your students, probably in middle school. They wouldn't have to create anything. They would just be touching the math and discovering pi. And using that basic concept, we then will expand on that, and we'll show you how your students in high school in a geometry class, say, could create that page on their own. Using the same idea, because pi is pi, we can't change that. We'll talk about gathering data points to fill lists and spreadsheets, and again, helping students discover pi in that unique way. And as Tammy discussed earlier, some basic programming on both the 84 and Nspire platforms is just another way for students to use technology to see the value of pi and where it comes from. Sometimes we kid with each other about how our students think that it's magic, and these are just lots of different ways where they see that it's not. It's just really good, fascinating math. And again, we do hope that at the end of the evening, there will be a chance to hear from you about some activities you use to excite your students about pi or just math in general.
So the basis for all of the activities that we're going to look at tonight is just really the idea that you can calculate pi by taking the circumference and dividing by the diameter. So every single one of the activities that we're going to look at tonight really kind of relies on that whole idea. So we're going to start by just looking at how we can use that idea in our middle school classrooms. So the first activity that we're going to look at is what we call discovering pi, and this is on a geometry page. So we're just going to switch over really quickly to our Nspire software.
Okay, so in this first activity, again, we would just send this to our students. It's nothing that they would have to create. So on Pi Day, they'd walk into the classroom, log into our class with the Navigator system, and then we would send this off to them. Without the Navigator system, we could just plug in and send it to them. So if we look at the first page with instructions, it just tells our students what they can expect. We've given them a circle where we've already measured the diameter and circumference, and we ask them to grab a point and to change the size of the circle. They'll then use their scratch pad to divide the length of the circumference by the length of the diameter and see what happens. And then we ask them to change the size many times and record at least 10 different quotients. So the goal here is for our students to do some basic calculations and discover for themselves, again, probably at the middle school level, where pi comes from. So they would go to the next page. And again, you can just see a basic circle. So maybe right here, they would just jot down that the circumference is 42.1 and the diameter is 13.7. And they would add a scratch pad and do that division. And here we get 3.15, which later will hopefully lend to a very good conversation. So then if they get out of their scratch pad and go back to their geometry page, we ask them to grab a point and change the size of their circle. It's funny, we did this earlier and everything was, there we go.
Still not moving. Okay, so I'm just going to skip ahead to another page. Something happened there. Okay, so what I'm going to do is just take a look at how to create this. So I'm going to go ahead and I'm going to add a page to my document and go ahead and add a geometry page. At this point, we're kind of working towards the maybe the more high school level geometry classroom. it depends on your students. You may want them to start building and constructing things in middle school. But at this point, I would say probably my geometry students would be able to handle this. So I'm just going to kind of quickly show you how you would create that document if it is something that you want your students to walk through. So I'm just going to go into my menu, and I'm going to start with just a segment. So I'm going to go into my points and lines menu, and I'm going to start with a segment that's going to be the diameter of my circle. And then what I want to do is I want to find the midpoint of that. So I'm going to go into my construction menu and grab my midpoint tool. And I'm just going to go ahead and point to my segment and go ahead and put a point on there. And so now I can construct my circle. So I'm going to go back into my menu and go to my shapes menu and choose circle. And so now to create the circle, all I really have to do is put a point on the center of my circle, or the point that I want to be the center of my circle, and click, and then go ahead and drag out the circle until it connects with an endpoint on my diameter. And then I can click again, and there's my circle. So the next thing that I want to do is I want to get some of those measurements on my screen. So I'm going to go ahead and choose menu and go ahead and go to my measurement tool. And I actually want to choose length. I want the length of the diameter. So all I really have to do is point to the diameter, and a little shadowy measurement kind of pops up. If I click once, now that measurement is attached to my cursor, so I can move it wherever I would like to put it so that it's kind of in a nice spot. And then click again and it will drop it. And then the next thing that I want to do is go to my circumference and actually point to the circle, and it will give me a measurement for the circumference. And again, same thing, the measurement shows up as kind of a shadowy image. I click once to get the image, or to get the number attached to the cursor, and then just move it to a spot that I think it looks nice. So at this point, the construction part is done. So I'm just going to go ahead and hit escape to get rid of that measurement tool in the upper corner. And now I should be able to go ahead and grab the point on my circle and move it around so that things change.
And for some reason tonight, now that we're live, the points aren't changing. And they always do until tonight.
Okay, I'm not sure why. All right,
that
so
actually might have been a feature. It might not be you guys. That might be a WebEx issue now that I'm thinking about it. So I apologize. I agree with Tammy and Robin that normally that's very dynamic, and you can just grab that point and just drag that circle out, and it just changes in real time. So the file that the participants are getting tonight, I'll double check, but that should work just fine.
Okay, thank you.
Mike, you'll double check the documents that we sent you that they're actually allowing us to click and drag?
Yep, I'm going to do that right now.
Okay, yeah, I think you're right that it's a web.
Thanks so much, everyone.
Okay, so on the next page, what we have are just some questions that we would send to our students. So what is happening? What did you discover? And at this point, we're kind of hoping that they come up with the idea that no matter what circumference and diameter they end up with, that they are getting a value around 3.14 when they go ahead and when they divide those things. And hopefully at that point, they have heard of pi or have seen pi at some point, and so then they start making that connection that that's where that value is coming from.
Yeah, that's great. So again, keep in mind that when this isn't live and the software is working on a handheld, our students by now would have collected about 10 values for pi, each individually, and then divided them on a scratch pad and gotten something around 3.14. And it was neat when we did it the first time that it came up 3.15, and we can begin to talk to them a little bit about rounding. And I think if I remember correctly, on our next page, we can actually show you, actually let's go back to the previous page and we'll show you how to create that calculation and show the way to unround it kind of for your students to see.
Okay, so on this page, the one that we're creating, if we want the calculator to display the value of pi on a own, so we don't have to go back and forth to Scratchpad all the time, what we can do is we can go into our menu and we can put a text box right on our screens. So if I go into my actions, one of the options in the actions menu is to add a text box. And so then somewhere on my screen I can just click and type in what it is that I want to display. And so in this case, I want to display the circumference divided by the diameter. And so I'm just typing in circumference divided by diameter. And when I hit enter, that pops up as an expression, circumference divided by diameter. And so now if I go into my menu and go back into my actions menu, and I choose calculate, I can calculate this expression, circumference divided by diameter. And all I have to do is click on it, and then it asks me a couple questions. It says, okay, well, what do you want to use for the value of your circumference? And that was this measurement up here, which is 32.3 centimeters right now. And so I just point to it and click, and then the question changes, and it says select the diameter. Well, that was this measurement, the 10.3 centimeters. So again, I'll point to it, click, and I get that measurement. And all of a sudden, it gives me the value of the circumference divided by the diameter, which in this case is 3.14. And no matter what I do to the circle, again, for some reason it's not moving, but if it was moving, if it was dynamic on the handheld or on your teacher software, when those values change, the value would still remain 3.14. Another thing that we wanted to have a conversation about is the way that my calculator is set up. It's set up to show just the 3.14 at this point, but with the students in upper levels, if you want to have the conversation about how pi goes on past 3.14, one thing that you can do is you can hover above the value itself, and if you hit the plus sign, it will start to show more decimal places. So if you just hover above the value and you hit the plus sign on your calculator, it will expand that decimal out farther so that you can have a conversation and look at more values just than the 3.14. And if you want to make that disappear, again, you can hover over and just hit the minus key, and it will take some of those values away. So that, again, depends on the level of the student that you're doing the activity with. In a middle school classroom, you might be perfectly happy getting to the 3.14 and having them see that value and go from there. Where in the high school classroom, you might want to talk about more digits.
Right. And when we measured earlier, we got 3.15 just because of the length of our circumference and diameter. So by hovering and using your plus sign, we could see that that was because of a rounding thing. So again, it lends itself very nicely to rounding conversations, depending on the level of kid. Okay, so for our next activity, we want to show you a couple of different ways of using lists and spreadsheets to calculate pi. We were going to do both automatic and manual capture, but now we're concerned because our software isn't letting us move our circles. We did capture some on our handheld that we could use to demonstrate how it would work. But unfortunately, the webinar is messing with our software a little bit.
But I'm still going to walk you through the process so that you can do this, especially if you're following along and you have your handheld. This is a really, really nice activity and a nice way for students to get a bunch of data values without necessarily having to write them all down or having to jot them all down. So the second activity that we're looking at, again, we're calling it collecting pi as opposed to the discovering pi, because this time what we're going to do is we're going to look at the data capture feature in the list and spreadsheet page. So if we go ahead and we turn to the page, it just says on the next page, move the circle around to see the change in diameter and circumference. And so if we do that,
So strange. control click on handheld. Okay.
Yeah. So on the next page, what you would do is start a listen spreadsheet page. And the way that this works is we would go from our circle and we would basically ask the spreadsheet to manually, or sorry, to automatically collect data as we move our circle. So the one thing that you want to do here is just jot down what your variables are. And so I will go through kind of quickly with this. All I did here is I took the circumference and defined it as a variable called circ for circumference. And then I took the diameter and defined that as a variable called diameter. So once you define those values or store them as a variable, then you can recall them in your spreadsheet. So if I go into my listen spreadsheet, what I can do here is I can go into this, this cell, and I can go into my menu, and one of the options is to look at the data. And within the data, I can capture data. And if I go into that menu, I have two options. I have automatic data capture, and I have manual. And so if I choose automatic, in that cell, it now says equals capture, and then it asks me for a variable. And so I want this column to be my circumference values. So remember, back on the last page, I had stored my circumference values using a variable name called circ. So if I go back to this page right here, and I hit my variable button, I have some options for variables at this point, and so I'm just going to ask it to recall that variable. So I called it circ, so I'm just going to choose circ. And then if I hit enter, it collects the value that's shown on the screen because that's the only one that it sees right now. So then I'm going to go over to this other cell, and now I want it to collect the diameter values. So I'm going to go back into my menu, go down to data, go into data capture. Again, I want it to do it automatically, and this time my variable name is diameter. So again, I'm going to go into my variable menu and choose diameter. And so now what it's done is it's collected a value for circumference and it's collected a value for the diameter. Now, if I go back to this page and try to move a point, what would happen when I move them is it would actually capture all those values that it sees as I move the circle. So if it ends up in a different spot, it would collect that value, and then you would see those values in the spreadsheet.
I can see through the chat that people are playing along with their handhelds, so you're seeing what happens. And I did see a couple of questions that we'll address in a second. But hopefully those of you who do have your handhelds out or your teacher software and are playing as you are watching, what you can see is that as you change the size of your circle and then you go back to your list and spreadsheets page, you now have many values for the circumference and the diameter. It automatically fills in your spreadsheet page. It's just a shame that for whatever reason, our software is fighting with the webinar tonight. So what we can show you is what we would do with this list and spreadsheets page. If it was completely populated the way we wanted it to be, we would then calculate the value of the circumference divided by the diameter in the next column. So again, remember we talked earlier about how our kids think that we make stuff up as we go along, that the only reason we celebrate Pi Day is because we're weird, and we want to show them that no, pi is truly circumference divided by diameter, and that there are many different ways that we can discover that. So this just using data is a different method to the madness. So let's show you how that would work.
So in the next cell, what I'm going to do is I'm going to tell the calculator that I want it to calculate the circumference divided by the diameter. So if you're familiar with the list and spreadsheet page, or if you're familiar with any spreadsheet software, Excel or Google Sheets or anything like that. In this cell, what I want to do is I want to type in kind of a formula. So I'm going to start with equals. And then what I am going to do is recall my variables. So I want to again divide my circumference by the diameter. So I'm going to go into my variables, and again, for this example, I called my circumference circ. So I'm going to choose circ, and then divide by the diameter. So again, I'm going into my variables menu and choosing diameter, and then just hit enter, and it calculates those values. And so whatever my circumference turns out to be, and whatever my diameter turns out to be, in this column, it's just dividing the circumference and the diameter.
Yeah, and if you notice at the bottom, again, it's very interesting for kids to see that there is a more expanded, of course we can't show every value pi, but it's much more expanded at the bottom. It's not just 3.14. So depending on your level of kid, again, maybe they just focus on that column, or maybe they look at the bottom and see, oh wow, look how far out this calculator can manage to calculate pi.
Yeah, and at this point what we wanted to do is go ahead and add, I'm going to add a page and go into a data and statistics page. So if we had more values, what we could do is we could graph this. And so what I would have to do in order to graph this is back in my lists and spreadsheet, I would actually have to name my list. So for this one, I'm just going to call this circumference 1, and I'm going to call this diameter 1. Just because I've used other variables tonight, you can use other things. And so now what I'm going to do here is just click on the bottom, and I'm going to add my diameter on my x-axis, and I'm going to add my circumference on my y-axis. And if I had more values, what you would see is a nice linear relationship at this point. And with my linear relationship, what happens is my my equation, if I were to go into analyze and run a regression, if I looked at the linear regression for this line, again, I would need more points. What you would notice is that the slope of the line turns out to be 3.14. So the slope of the line is pi. And again, that's a nice little connection for students to see the relationship between the circumference and the diameter.
Hey, Tammy.
Yeah.
Before we move on, we had a couple questions I was hoping that maybe we could answer. One is from Natalie, and she was wondering, whenever she was working through this, she had the 3.14 that filled the entire column down before she had the circumference and the diameter dragged. So any idea why that's happening?
No. It happened on ours as well. I'm just thinking.
Okay, while you're thinking about that, because I wasn't sure of the answer either, we had another question from Camilla, and she was wondering if you had a class set of these Nspires or if your students are required to purchase them.
We actually have class sets for our students. Each classroom in the high school has a set of enough Nspires for the students to use in the class. Some of our upper level classrooms have, the students are able to sign them out. We don't require the students to buy them, but some of them do choose to buy their own.
Thanks so much. And then Sean just added, if instead we have just defined it as C1 divided by D1, that would not have filled it in until we actually pulled and dragged. So
yep,
thanks, Sean,
right.
for that extra comment.
Yep, and I hadn't named the list. Yep. Thank you, Sean.
Any other questions out there before we move on?
I don't see any other questions, but I was thinking maybe that we could just give my computer a shot just for a second, just because that dynamic changing of the circle and showing pi is, I think, pretty important. So, Tammy, can you do me a favor, just stop sharing for a second, give me control back, and I'll share my screen. We'll see if I have any more luck.
Okay. I might try to restart my software, too.
Okay. So I'm just showing my screen with the same file that Tammy and Robin were just using. So if I go to page 1.3, so as I'm changing the circle, I don't know if you saw, but a few seconds ago I didn't have any data whatsoever on page 1.4. And now I have a good bit. And then if I go back to discovering pi, which is one of the first things that they shared, I think Tammy and Robin, you guys were trying to change this circle dynamically.
Right. We're watching you work underneath our restart of our software.
Okay. It might be a Mac issue depending on what operating system you're running tonight. I hadn't thought about that. So if you want, I mean, I can continue to roll, or I can, we can wait for your software to power back up, and then I can give you control back.
Yeah, if you want to run yours, and then once mine starts back up again, we can take a look.
Sure. Do you want to go back to the PowerPoint?
Well, let's, so we just showed the automatic data capture. We just have to get you out from behind this startup screen. Maybe we could talk through the manual data capture next.
Sure.
Now, since your circle's dynamics.
So, Michael, I think if you move ahead a couple of pages on that document. So what we have here is basically the same circle, but this time I just used different variables. So this time I called the circumference, and I called the diameter just D. And then the next page in this document is another list and spreadsheet. And so with this one, what I did is if you go into that equals cell again, up at the top underneath where you can name them, and then you go into menu. Under data, we have the data capture menu option again, but this time we're going to choose manual. And with the manual option, again, we can put our variables in there. So in this case, the variables were circumference for circumference, and for diameter, I used just D.
So just double check, we're good with the way it's going to capture?
Looks good.
Looks good, yep.
So then we're going to go back to page 2.2.
Yep. And then if you just change your circle.
And mine's not working now. Oh, there we go. Sorry.
There it goes.
And so if I want to capture this, how do I do that?
So you want to hit Control and then the decimal point. So the main difference between manually capturing and automatically capturing is with automatic, it'll capture every data or every value as you move your circle, where with manual, you have more control. So you may not collect as many values along the way, but you can collect specific ones. And so again, for the different level of student, they may only need a few values to see the connection, and for others, they may want to see more. So with this one, you may want to have, you may want to move your circle a couple times, and then just control and capture, or control in the decimal point will give you values, And then if you go back to your list and spreadsheet page, you should be able to see the exact values that you collected.
Great.
So this is kind of cool because you can give, each student, say 3 or 4 different points to capture, and you can really kind of see as a class how everyone has all these varying different data points.
Right, and then if you're fortunate enough to have the Navigator system, you could collect each individual student's data and then combine it into one list and spreadsheet and send it right back to them. So they'd go from maybe 4 data points to 80 data points if you have a class of 20 in the matter of seconds. And so what kids really like about this and what we really like about this is, once again, it's their data that they've collected, and so it's real to them. It's not something that we've just handed out and said, please believe me, that pi is circumference divided by diameter. So just a couple of different ways, once we get software up and running and behaving itself on a Tuesday night, to use our technology to help kids understand the meaning of pi.
Awesome. I'm glad it's working.
Yeah, me too.
Do you want to show the data and statistics page?
Sure.
Okay.
For the same document?
Yeah, we can just go ahead with what we have on the screen here. So in your cell A, if you want to call it something related to circumference.
Perfect.
And then B will be something related to diameter.
And notice, as he's picking it, for those of you that may not be as familiar with the list and spreadsheet, if he just stuck with D, it's bold. We've already used that, so we need to change it up a little. So even just DI would be okay, or DIAM. As long as it stays italicized, that's a new variable name that we can use on our next page, just to clarify what's happening there.
So if we go ahead and we add a data and statistics page.
So I think we add pages by control doc is one way?
Yeah.
And so at this point, what we have are a few data points just randomly kind of scattered on the screen. And so on the very bottom of our screen, we have that place where it says click to add variable kind of along the x-axis. And if we click there, our variable name should pop up, and we want to put our diameter on the x-axis. And once we choose that, the points will kind of start to organize themselves a little bit. And then we're going to go over to the side of the screen where it says click to add variable on the y-axis. And we can add our circumference values in. And so even with the few points that we collected, it does look to be linear. And so at this point, if we want to analyze the regression or look at the regression for that, we can go into our menu and to analyze. And under the regression menu, we can choose linear. And the line is drawn, and the equation of that line is also shown, and we can see that the slope of that line is 3.14, which is our value for pi.
Awesome. Thanks, Mike, for helping out with the software.
No problem. You guys ready for me to give control back to you?
I think so.
Yeah, it should be fine in the coding.
All right, Tammy, it's all yours. Feel free to share your screen.
Okay. Okay, so just to go back really quickly, with the coding part of tonight's webinar, I just wanted to mention that Robin and I are not experts in programming or coding by any means. With the activities that we're going to look at, we basically kind of modified some of the activities from the TI 10 minutes of code. So if you haven't been to this website before, it's part of the education.ti.com website, and other activities. And with this, they have activities to help students learn how to code that take very little time out of your class. And so they offer them for both the 84 and the Nspire. And so what I'm going to do is show you some pretty simple ways that you could introduce coding on Pi Day without really spending too much time having to go over all the pieces, all the parts and pieces for coding. So the first activity that we're going to look at is just a very simple program that allows students to take that same document that we were working with, our geometry page where they have the circle and the circumference and the diameter, and they're recording values for circumference and diameter. But this way we're going to program so that the calculator will ask them to put in values for circumference and diameter, and then we'll spit out the value of pi. This activity is very, very similar to one that I found on the 10 Minutes of Code, which is in Unit 3 Skill Builder 1. So if you're interested in something similar, maybe not necessarily for Pi Day, but you want to try something like this with a different formula in your math class or whatever class you want to use it, then that would be a place to go. So that's kind of where I got the inspiration for this activity. So if we switch over, okay. So just quickly to kind of look through the program for this. And again, I will walk you through where all of this comes from and how to create it. But all I did for this is I started a program called Pi1. So with the Nspire, when you start to program, you have to name your program. And then all I did was I told the calculator to request or to ask for the circumference, and then I stored that value as circ. And then I asked the calculator to request a value for the diameter, and then have it stored as a variable called diameter. And then the calculator is going to display the circumference divided by the diameter, and then that's it, the program is done. With this, if you want to test your program and see if it's going to run, if you hit Control-R, it will store it, and then it will bring you to a page to allow you to run it. So basically, it will bring you to a calculator page. At this point, if I enter or hit enter, it will run the program, and it's just spitting up the values that I tested before. So we did jot some down as we were going through. So one of the values that we used for the circumference, or that we found for the circumference, was 43.1, and then I'll just hit OK. And the diameter at that point was 13.7, and again, these are just from the circle that we were moving around on our geometry page. And then if I hit OK, it comes out and says, okay, the circumference was 43.1, the diameter was 13.7, and your value when you divide them is the 3.15. Okay, and so we can run that again. If I run that program again with other values, if I check another one we jotted down was 50.3 for the circumference and 16 for our diameter, and again, when I divide them, I get 3.14 for that value. And so again, it's just another way to do the same type of activity and find that value of pi. But you're using coding, you're using programming along the way. So really quickly, just to show you how that all works, if I start a new document, when I start a new document, the first thing that pops up is the list of pages. And so in this case, I'm going to go to my program editor, which is choice number 9, and I'm going to write a new program. And so I do have to name it, and so I'm just going to go with Pi4 because I don't remember how many different versions of Pi I have stored at this point, and I'll just choose OK. And so at this point, I have a name for my program. It says that it's going to be a program. And now all I want to do is I want to request from the user a value for my circumference.
And just real quick, I want to mention that one of the really nice things about the TI coding is that it gives you that shell. So kids don't have to worry about some of the nuances of coding at this point. The program, end program is there, and then there's that little blank box for them to start programming in. So it's a nice kind of starting point for what we call line coding instead of some of the earlier coding that they may have done in elementary or middle school.
And so pretty much anything that you need, you can find in the menu. And so at this point, we're going to request something, which is in the I/O or input-output menu. And so we're going to request, and now whatever we type in quotes is what's going to pop up in the dialog box. So I'm going to request C equals for circumference. And then whatever value gets typed in, I have to have it stored as something. So I'm just going to choose CIR for circumference at this point. And then I also want to request the diameter. So again, I'm going to go back into my menu, and in the input-output menu, I'll choose request again. And this time I want them to ask for the diameter, so D equals. And I'm going to store that as DIA for diameter. And so now at this point, the calculator has two things stored. It has the circumference stored, it has the diameter value stored. And so the next thing I want it to do is display or show the value for the circumference divided by the diameter. So again, in that input-output menu, one of the choices is display. And so I can have it display the circumference, the circumference divided by the diameter. And I have to make sure that those values match the values that I stored them under. And so now, if I save my program and I run it, if I type in a circumference value and a diameter value, I get my value of pi. And so really that's very, very basic coding. So I would say students at almost any level with a few prompts would be able to make that happen and type those values in. So really, really very basic.
Okay, the last thing I think that we'll show you tonight is a similar program on the 84. Again, we found this, something like it in TI's 10 Minutes of Code under the 84, Unit 2, Skill Builder 1. So we'll show you the program, talk you through quickly how to actually write the program, and then have a bit of time for questions and other ideas. Oh, and maybe a quick little cameo by Timmy Sun.
Okay, so on 84, if I go into my programs, at this point I have 3 programs that are stored in here. So if I go into Edit and I choose Pi and we look at it, this is pretty much the exact same program that we looked at on the Nspire, but it's the 84 version. So it's going to prompt the user to enter a value for C and D, which will be the circumference and the diameter. And then it's going to display the circumference divided by the diameter. If I quit, so second quit, and go back into my program, and I want to run that under my execute menu, if I choose Pi, it's going to run the program Pi. And so if I hit enter, it's going to ask me for a circumference value. And then it's going to ask me for a diameter value. And then it will display 3.14. It'll display your value of pi.
So again, quick and easy, real intro programming for kids, but again, as much exposure as we can give to programming and coding as possible, the better.
And so really quickly, just to kind of show you how that works, if I go into my new menu, I can create a new program, and I can call it, let's do pi. Whoops, sorry. We'll go 4. And so with this one, if I go into program, I still have the same menus. I still have that input output. There's my menu for prompt. and then comma D for diameter. And then I want it to display the circumference divided by the diameter, and that's my program. So I've stored it, and so now I can exit out. I can go into my program, I can run it, and again, it will ask me to put in a value for the circumference, it'll ask me to put in a value for the diameter, and it will pop out the value of pi.
Okay, so how are we doing in the chat, Michael?
So far, good. We had one question that I wasn't sure if we could answer tonight if we had time. Maybe you can think about it. The question was from Elaine, and she wanted to know if you had a program that could approximate pi using an inscribed polygon or circumscribed polygon with an increasing number of sides. Like I can kind of picture what that looks like, but I don't have anything written right now.
I don't have anything written either, but it'd be fun to write.
Yeah, it is something that we could play around with and see if we could come up with something that would work and share it.
Other than that, I think earlier in the chat window towards the beginning of tonight, John had shared a link with some information that he uses for Pi Day, something that he had written for a T-Cube conference a few years ago. So a few people have left that link and were commenting that the materials are really nice. So John, thanks so much for sharing those materials.
Awesome. Thanks, John. So one of the things we just wanted to share with you at the end was a kind of non-techie way of celebrating Pi. As we started the webinar out, we mentioned that we've been celebrating Pi Day for a number of years, probably 15 years or so in Lake Placid. And it started kind of basic, you know, we'd have kids, we color-coded the digits and they made, you know, little chains like you might put on a Christmas tree or whatever, a paper link chain that represented pi. One year we hooked up with our PE department and we had a carnival in the gym, and we just had all different stations of ways of discovering pi or creating pi, or we even had our principals sign up and they had a pie in the face contest, you know, and that went to, the money went to charity. And so we've done all different kinds of things. Another year, for whatever reason, the Mickey Mouse Clubhouse song popped into my head, and I wrote a little song about Pi Day to it. And then at a conference, actually just the T-Cubes conference last week in San Antonio, Tammy met someone who showed her a Pi Day handshake. So we made a little video to show you a non-techie way of celebrating Pi with both the song and the handshake, and giving credit to one of our math colleagues for the handshake. And I think we'll probably end up closing with that and then some final questions. Assuming this technology is going to work. It's been one of those nights. Here we go. Full moon. So just one quick, silly little way to celebrate Pi with kids.
Thanks so much, Tammy and Robin. Just for everyone that is on tonight, you are going to receive a copy of the PowerPoint that Tammy and Robin used, and I can see that on the last page of that PowerPoint is a little video clip. So it was a little tough for me to hear, but I'm betting that whenever those have a chance to download it, it might be a little bit easier.
Awesome. Any last minute questions from the crowd?
I don't think any last minute questions. I didn't see any, but we do have a few people. I think Jane is mentioning some thoughts about what she has done with her students on Pi Day. So as we begin to wrap things up tonight, feel free to, again, include some of those It's great to hear what you have done on Pi Day.
Great. Thanks, everyone, and thank you for your patience with our strange little tech issues tonight. That usually does not happen.
No problem. Tammy, feel free to, if you don't mind, giving me control back.
Sure.
Thanks so much. So as we begin to wrap things up tonight, if you do have any last-minute questions for Tammy or Robin, please try to get those asked. I know they'll do their best to try and get those questions answered. One thing I did want to share on our website, as Tammy and Robin were showing some of the material that they did tonight, I was looking under the Activities tab on our website and move under the 84 Activity Central. I know there were a lot of you that were looking for additional activities that you could possibly use for the 84 on Pi Day. And just to highlight one, if, again, you move under the 84 Activity Central tab and the Geometry tab on the left, slide down to Perimeter, Area, and Volume. And there's a really nice activity that says called Diameter and Circumference of a Circle, written a couple years ago. Again, this is specific for the 84 plus family. So please feel free to take a look at that activity. That's going to be free to download, and it's going to be using Cabri Jr. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events. We really hope you share your thoughts, and we definitely listen to your feedback. To receive a certificate of attendance for tonight, go ahead and click that link in the chat window. Also listed is a link for the documents, as I mentioned, that were used tonight by Tammy and Robin. If you happen to miss this for any reason, feel free to just hang out for a couple days. You'll automatically get a follow-up email. In that follow-up email will be a link to the recording, as well as a link to the certificate and the documents. If you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Once you leave the webinar tonight, if you do have any last-minute questions that occur after the webinar, feel free to give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. We'd love to hear from you. Thanks so much, everything. Thanks to Tammy and Robin for everything you shared tonight. I really appreciate it.
Thanks, Michael.
And happy Pi Day, everyone.
Absolutely. Happy Pi Day, everyone. We hope to see you back online next week. Have a great night.